Metaprogramming in Elixir is a feature that allows developers to modify the language's abstract syntax tree, referred to as the AST, which improves its extensibility. In simple terms, metaprogramming is the ability to alter how a program is interpreted by changing its structure. Macros, which are a subset of metaprogramming, play a crucial role in achieving this goal. They are one form of metaprogramming that is useful for inline modifying. You can dynamically add functions or code to modules. The beauty of Elixir is that it is built mostly from the same macros that you and I can write in our own libraries, which makes the language highly extensible. You might be wondering what an AST even is. It's a simple data structure in Elixir's own terms. We can use quote to return the AST representation of any expression. So let's go ahead and open up our terminal and let's start just the Elixir shell. So IEX. Using the word, or the term quote itself is actually a macro, but what it does is it will return the abstract syntax tree. AST, I'll call it AST a lot in this video, but it returns that representation of whatever code we're doing. So if I did something like this, quote do colon, and then we just do 1 + 2 and hit enter, you're going to see you're going to see a tuple, right? And it's very readable. You can go through it right here and you'll see, the first term is an atom. The second value here is a list. And then the third parameter in this tuple is a list of values. And you're probably already kind of piecing it together, like we did 1 + 2. So we see an atom plus there, and then we see our 1 and 2 as arguments right there. And we can do this for anything. We can do quote we can do divide. We can say 4 divided by 2, and that returns the AST as well. And so quote gives us the ability to peer into the internal representation of our code with a data structure you already know and understand. The first element is an atom denoting the function call, or it could be another tuple representing a nested node. So in our case, where we did 1 + 2, this is the atom denoting a function call. So this is calling a function called plus. And then in our division, it's calling a function called div. And the second element represents just metadata about the expression. So you just see context Elixir. It imports some functions from kernel, and same thing with our division here. And then the third element is a list of arguments for the function call. So we have 1 + 2. The first argument is the first one in the list. The second argument is the second. And then same with division. The first one is 4. And the second one is 2. So why use macros for Elixir's own constructs? It allows us to extend the language with our own keywords while using existing macros as building blocks. When you use quote, it returns an AST representation of any expression. Macros receive ASTs as arguments and provide ASTs as return values. So by writing macros, we're building ASTs but using Elixir's high-level syntax. So the syntax we're used to, just writing Elixir code, There are, when you do multiple things, so let's say we're going to multiply, subtract, and add, what do you think we're going to get back? So if I do a quote do here, and we do 4 × 3 - 2 + 1. What's going to happen when I hit enter here is we're going to get what is called multiple tuples that are stacked in an embedded tree representation, but it's still a simple AST. And if you go ahead and look through this, you're going to notice that where the function is in the first parameter of this tuple, as we go down, we have embedded, basically just embedded tuples all the way down in the order of operations. So multiplying is first, so it's the very inside piece of the tree. And then we're going to be subtracting, so that's the next one. And you can see that, look, we're multiplying 4 times 3. And then look, we're subtracting whatever we get here. We're subtracting 2. And then we're adding whatever we get back by 1, and that's in the far outside of this tuple. Now, it's probably a little confusing to follow this in the terminal, so I made a little diagram for us, and that is maybe too big, honestly. Let's just relax a little. All right, so what we did here is we did 4 times 3 minus 2 plus 1, and that's the order of operations. So the very inside piece of our tree is 4 times 3. And then this value that we get back, we're subtracting 2. And then that value that we get back, we're adding 1. So it's just a bunch of nested tuples in the abstract syntax tree structure. And hopefully this helps you visualize it a little better. Now, another thing to know is that many literals will have the same representation within the AST and high-level source. And when I say high-level source, I just mean like Elixir language. So some of these include atoms, integers, floats, lists, strings, and any 2-element tuples containing any of the listed types that I just said. And what I mean by that, so if I do quote do, and I just pass in an atom, we get exactly the same thing back. So atom, okay? So if I do quote do, and then we pass in a float, so 556, we get 556 back, okay? And if we do quote do and pass in a string, we get a string back. And then, like I said, any tuple with any of the above items, so if it's an atom, integer, float, list, or string, you're going to get the same representation back as well. So if I do quote do, and we pass in a tuple with like an OK atom, like you see this as function responses all the time, right? And then we can pass in a list with items 1, 2, 3. And then if we close that tuple, when I hit enter, we get the same exact thing back. Now, if we were to do this to a map, we're not going to get the same thing. So if I do quote do, and then we create a map here, and then let's say like we just have a key 1, and we'll say a string called value 1, and then we'll do key 2, and we'll say value 2 as a string as well. Now, when I hit enter, you're going to notice we get our AST back. And what's really cool is, look, it's calling a function that to us looks like an empty map, right? But this is actually a macro. So this macro under the hood is just a key value list. So we've learned that quote is used to generate an AST. What does unquote do? Because I'm sure just writing code, you've seen quote and unquote used a lot, and you probably don't understand them. So go ahead and Control-C twice to close out of our IEX shell. All right, and I'm just going to CD to my desktop and create a new project. So mix new, and we'll call it macros. It already exists. Yeah, let's go ahead and CD into that project, and then let's open it up with VS Code. I'm going to just at the base level, right inside the root directory, let's create an Elixir script file, and let's just call it intro.exs, and then just make it a def module. So like we always have, and it's just going to be called intro. All right. And now inside of this, we're going to write our first macro. So if we do def macro, and the name of this one, we're just going to say display underscore value, and it's going to take a value. So a macro must return an AST. Okay. So we need to have our quote block. So quote do end. And inside of here, all we're going to do is return the value we passed in. So we're going to do IO puts, and we're going to say, this is the value, and then colon, and then go ahead and do a pound, and then opening curly braces, and we're just going to pass our string or our value, whatever it is, through, and then we'll return the value, so we have a return value as well. And then I'm going to save this, and if we pull up our terminal, and let's go ahead and boot up the IX shell for this project. So IX space dash capital S mix. All right, and since this is an Elixir script, we're going to compile our file, and that is called intro.exs, and it needs to be in quotations. So intro.exs, so just a C space, okay? Intro. Oh, I put it in the library on accident. That's fine. All we have to do is just do lib / intro.exs. All right, and it's telling us that value is unused. And we're just going to go ahead and use this though. Still, we're going to just, I want to get an error, so then we can explain how unquote is used. And with macros, if you remember in our older lesson where we went over use, import, and require, basically require will import all macros that are in a file. And if you, I believe use does all functions and macros. So we're going to just say, require intro. All right. And then we can do intro dot display value, and then we can pass in a string, a word. All right. And then when I hit enter, we're going to get an error. So undefined variable value, context intro. So the error that we're running into is basically because we don't have access to this variable because it is outside of the context of quote. So anything like up here or even here would be outside context. And now what unquote does is it allows us to inject a value from the outside context. Enjoying the video? Show some love with a like and hit subscribe to stay updated. To support me and keep the content free, click join for memberships or pick up a course at elixirmentor.com and get free access to my private community. Let's jump back in. All we'd have to do in this case is use unquote, and then we would have access to this value. So since we're using it twice here, I'm just going to say value equals, and then we're going to say unquote value, okay? And now when I save this, now our value will be injected into our macro, and we'll run this code, and then it will return to us. So now I have to recompile. And now when we pass it through, we now see that we have, this is the value, a word, and then we're just returning the string as well. So anytime that we're writing a macro, when you're within the inner context, which is anything in this quote do block, we have to use the unquote macro to inject the value that we want to inject. Let's do a little better. Let's revisit our shopping cart example, and let's build a macro to add and remove items from our cart. So let's make a new file. And we'll make a new file, and lib directory is fine. Let's just call it shopping.exs. Okay, and then it needs to be a def module still, and it's going to be called shopping. Since a macro takes an AST for an argument, since we know what a structure will look like, we can pattern match to that AST. And so let's first make a macro that's going to accept a list, which is our cart, and then we're going to want to add an item to it, right? So if we went ahead and just did def macro here, and inside def macro, and let's just call it cart, and then the parameters we want to pass in, we want to have the form of an AST. So it's going to be a tuple. And let's pattern match. Let's say when we add an item, we just want to have our cart list plus whatever item we're adding. So we would want to call the function the atom plus. Okay. And then the context of the AST we don't care about, so we can just have an underscore there. And then our arguments that we want to use are in a list, and our first argument will be our cart list. And our second argument is the item we want to add to our cart, okay? Now, when we looked at the AST of adding two integers before, and we saw it calling an atom plus, and then we saw the metadata that we don't worry about, and then the list with the left and right hand arguments. So the similar thing is happening here, okay? And then inside this, we are going to need our quote block, okay? And this ensures that not only is our cart taking an AST, it's returning an AST, right? Now, for us to have any access to these variables, we need to use unquote. So now we can say we want our cart to equal unquote cart, and then we want our item to equal unquote item. And now we have access to those. And so now, like, we've already done things like this. So now all we'll have to do is prepend our existing cart and return the new list, right? So we can just do new cart equals, and then we can just, inside of this list, we can say we want our item to prepend to the existing cart. All right. And we can even do a little, we can even do a little IO puts message that we can get in our terminal. And we can say added, and then we can insert our item here, and we can say to the cart, and then we can say new cart colon, and then we can just, since it's a list, we have to do inspect and pass our cart in. And now we'll return a message that says added, like apple, to the cart, and our new cart contains, and it'll return all of the items. And then we'll just return our new cart list. So let's go ahead and like test this. How does this look like in the wild now? So we pull up our terminal. First of all, let's recompile. Or compile it in the first place. We need to compile our lib.shopping.exs file. Okay, and then we need to require it, so we have access to our macros. So require shopping, and then all we have to do is say shopping.cart, and we can do, well, we could start with an empty list, or we could have a list with an apple already in it. And then we can just say plus, and we're going to say, let's add a pair. And now when I hit enter, we look at that. We have our little IO puts, added pair to the cart. Your new cart is now, we have to, we want to return new cart here, not the cart. So save that. Let's recompile. And now, there we go. When I add the pair, we get our new cart back with pair prepended. So it's in the front of the list. And then it returns just our cart. So that's pretty cool. All we have to do now is, like, we made a macro called cart. And we can now say, like, we can take line V9, and that's going to be an apple and a pear. And then we can just add an orange to it. And there we go. we wrote our first super simple macro, which is, I think it's pretty cool. We're not even scratching the surface in this video. This is just, dipping our toes in. And now we can do the same thing, but for removing an item. I'm just going to copy this and paste underneath. And now we're going to do a minus here. And we still need access to both our cart and item. So we're using the unquote to inject those variables. And then our new cart, instead of prepending an item, we can just do list.delete and pass in our cart, the list, and then the item that we want to delete. And we'll just say we removed item from the cart. And then our new cart will return. And there we go. So now if we save this and go back to our terminal, let's recompile. And then we can just go ahead and, like, if we pulled up our shopping cart, 10 from line 10. And let's see. I'm going to delete this. I want to just make sure V10 is our list. So we have 3 items there. And then if we do shopping cart or shopping.cart, and if we just do V10, and now if we do a minus, we can remove any of these items. So I can do minus pair. And then when I hit enter, it removed pair from the cart and then returned our new list, which is just an orange and an apple. The quote and unquote macros pair together to help us build ASTs, and without actually having to build the ASTs by hand, which makes things so much easier. So we're basically allowed to write macros that at a low level are using ASTs, right? But we are writing normal Elixir code, which I think it's pretty awesome. And so now if we were to dive a little deeper and what exactly is happening with macros at compile time. When the compiler encounters a macro, it recursively expands it until the code no longer contains any macro calls. And so what does that mean? That means, like, for instance, if we were to expand the macro that we just wrote, what we can do is we can just do, I'm going to save it to a variable called AST. And then inside of this, I'm going to say quote do. We're going to just have multiple lines here. And if I call shopping dot add, or I'm sorry, dot cart, and then we add our, let's say we have our apple in an existing cart, and then we plus and add a pair. So this is just going, we're putting this in a quote block so we get back our AST, okay? And then if I just end this block and hit enter, we get an AST back, okay? Our AST contains some other macros in it. And if we wanted to expand this, we can actually use macro expand. So if I did macro.expand and you pass in the AST you want to expand, which is the shopping cart add macro that we just wrote. The second argument is just the current environment, and we can pass that in like that. And now when I hit enter, we're going to get a crazy list of things going on. This is the abstract syntax tree, and it represents Elixir code, an Elixir code block. So let's break it down a little bit here. I'm scrolling up. Let's see. Let's find the top here. Okay. The code block starts with this atom __ block, indicating that there's a block of code. And now inside this block of code, there are several expressions going on. So right here is where we're assigning our cart to our cart variable. And then down below, we're assigning our pair to our pair variable. This is our unquoting when we're injecting our variables. And then as we go down, you'll see that this is where we're assigning and creating our new cart. So this is the prepend function. And this is the item being prepended to the cart. And so we're just working our way through, and then you can see things like the IO puts, and you can see our string where we said we added something to the cart. And then in the middle of this, though, is our interpolation where we're inserting the item that we're adding on our cart. And you can just go all the way down and through this, which is pretty cool. And then we get to the end here where we're returning our new cart list. And obviously, it's readable, but it wouldn't be the easiest thing to create this by hand, which is really nice that this macro, this AST tree, was made by just writing a macro in readable Elixir code. Metaprogramming is a powerful tool in Elixir that allows you to write code that writes code. By understanding how to use macros, quote and unquote, you can create more flexible and expressive programs. In this video, we've scratched the surface of what's possible with metaprogramming in Elixir. As you continue through this module, you'll learn more advanced techniques and best practices for using metaprogramming. So keep experimenting, exploring, and having fun with Elixir's metaprogramming capabilities, and I will see you in the next video.